Hello, welcome to my channel. Today, I am going to show you how to create a Visual Studio SSIS package that checks the system environment and dynamically imports data from an Excel file to either a development or production Oracle database server. This video is a continuation of the previous one. If you are not familiar with the basics of the data flow task, I recommend watching my earlier video first. The link is provided below. Now, let's open the SSIS package that we created previously. Select the .sln, the solution file, and open it with Visual Studio 2019. I have renamed the existing ADO.NET Connection Manager to Oracle as Oracle ADO.NET Development. You can rename any connection manager by editing its name under the properties. Now, we can create a production connection manager by duplicating this one. Therefore, copy and paste, then rename the new ADO.NET connection as the Oracle ADO.NET Production. Right-click, then Edit the Oracle ADO.NET Production Connection Manager. Here I pretend that my production server is the same machine, but you can change the server name and login credential to point to your production server. Enter the password and click Test Connection to make sure the connection is working properly. Normally, your development and production servers are two different boxes. So, remember to edit the connection manager after duplicating from an existing one. Now, we have two Oracle ADO.NET connection managers, one for development and one for production. Let's select, right-click, then disable our previous task flow. For demonstration, we will create a new package. At the right-hand side, right-click the SSIS Packages folder and select New SSIS Package. Right-click the package one. Rename it as Dynamic Package.dts. Click Yes to all to allow this renaming. The purpose of creating this new package is to show you that first, we can have multiple packages in a project solution, and second, we can share the existing connection managers among packages by converting them into project-level connections. So, let's convert the Oracle ADO.NET Production, Oracle ADO.NET Development, and Excel Connection Manager into a project-level connection manager. You can see that a parenthesis project label has been added to the name of the connection manager. We just promoted the package-level connection managers to the project level. The project-level connection managers can be used on any packages in this project. This avoids the need of maintaining multiple connection managers that connecting to the same server among packages. Now, we are in the Dynamic Packages Control Flow pane. Let's drag and drop a data flow task to the Control Flow pane and label it as Development. Right-click the Data Flow Task Development and select Edit to open the Data Flow pane. Drag and drop an Excel source to the Data Flow pane. Right-click, then Edit to configure the Excel source. The Excel Connection Manager has been automatically selected, therefore, select Sheet $1 as our Excel sheet. Click Preview to see the data on the Excel file. Yeah, the birthday has been misspelled as Dirthday. So, let's take a few seconds to fix the problem forever. Open the sample_data_97-2003.xls Excel file and change the Dirthday to birthday. Then, save the Excel file. Close the Excel file. Now, go back to the Visual Studio, open the Excel source again, preview, and check the data again. It spells birthday now. That is good. Click Columns. Wonderful. The input and output column names all look good. Now, drag and drop an ADO.NET destination to the Data Flow task pane. Drag the small blue arrow under the Excel source to connect it with the ADO.NET destination. Right-click the ADO.NET destination, then edit the configuration of this ADO.NET destination. The connection should be the Oracle ADO.NET Development, and the table name is Sample Dataset. Click Preview to see the existing data in the Oracle Development Server. Click Columns to make sure the column mapping and column names are all well. Click OK to close the Editor dialog box. The Data Truncation warning icon shows up, but we know that will not be a problem. Later I can show you how to remove this warning icon. Now, click the Control Flow tab and go back to the Control Flow pane. Before we continue, let's jump to the Oracle database server and create the table to receive the production dataset. Here, I will simply copy the table creation query from the sample dataset table and edit the SQL script a bit to create the production dataset table. Execute the new SQL query, and we just created a table to hold the production data. Let's jump back to Visual Studio again. Copy the data flow task for development task, then paste it on the empty space below. Adjust its position and rename it as Data Flow Task for Production. Right-click the Data Flow Task for Production, then click Edit to change its configuration for the production server and table. Open the ADO.NET destination. Change the connection manager to the Oracle ADO.NET Production. Also change the table name to Production Dataset. Click Preview, and we see the empty production table. Click Mapping, just to make sure the column mapping is all well. Click OK to close the Editor dialog box. Save the project, then back to the control flow pane. So far so good. Yeah, move the two boxes of the data flow tasks to create some spaces. At the right-hand side, double-click the project.perms file. We need to create a project-level parameter called ProductionServerName. Its data type is a string, and enter your production server hostname in the value box. Later, we will base on this project parameter to determine what environment we are in, and then based on the environment variable to execute either the development or the production data flow task that we just created. Now, click the Dynamic Package tab and open its control flow pane. Here we also need to create a package level variable called environment. The reason that it has to be a package level variable is due to that we need to write or assign a value to it. Go ahead, add the variable, name it v_environment. Its data type should be a string. Leave the value to be a blank space for now. Close the variable editor. We got everything ready. All we need is to create a script task and use the script task to evaluate and assign either a production or non-production value to the v_environment variable. Therefore, drag and drop a script task to the control flow pane. Right-click the script task, then Edit. In the read-only variables field, click the three little dots at the right-hand side to open the variable selection dialog box. Select system::MachineName and $project::ProductionServerName as our input variables. Click OK to close the dialog box. In the read-write variables field, click the three little dots at the right-hand side to select the user::v_environment as our read-write variable. Click OK to close the dialog. Now click Edit Script to open into Visual Studio Code Editor. The script task has auto-populated with a sample code. It provides valuable information on how to edit the code. So when you have time, you can read through the instruction. Now, let us add our own code into the public void main function. Our logic is very simple. If the system machine name is equal to the production server name, then the v_environment variable should be assigned as production, otherwise, the non-production should be assigned to it. Please be very careful. The parameters and variable names and values are all case sensitive. Do make sure you have entered everything exactly and correctly. If the script task failed, it is most likely that the names are wrong, or the variables do not exist. If you need to output something to help troubleshoot, you can use MessageBox.Show function to pop up a value for you to check your code. When you are ready, save and close this Visual Studio Code Editor. Then you will find yourself at the original Visual Studio's Script Task Editor dialog box. Click OK to close it and return to the control flow pane. Let's execute the script task and make sure the script task run well. And the pop-up tells us that there is a discrepancy between the system machine name and the provided production name. Therefore, we know we are at a non-production environment now. However, do you notice that something is wrong with the script task? Let's open the script task code editor again and uncomment the MessageBox.Show function. Save and close the code editor so that the pop-up window won't interfere our task flow. If you still have the SSIS SSIS Power Pack installed, you can do a test like what I demonstrated here. Add a ZS logging task to the control flow pane and connect it with the script task. Edit the ZS logging task and change its log method to using MessageBox, and edit the message to show the user::v_environment variable. You can see that my script task would not run. It failed. So, let us do some troubleshooting. Luckily, I am able to identify the v_ environment as having a lowercase e in the script task variable name coding. I should change it to use the uppercase e. Save and close the script task code editor. Execute the script task again. The problem is solved. So, remember to enter the code very carefully. For your convenience, I put a copy of the script task code below in the video description section. Now, let's connect the script task to the data flow task for development, and also connect it to the data flow task for production. Now right-click and select Edit, the green-colored arrow that connects to the For Development task. Change the evaluation operation to expression and constraint. Then click the three little dots, then edit the expression as at user::v_environment, not equal to production. Click the evaluation expression button. The result is a true. This is correct. Our current setting is a non-production environment. Click OK to close the editor. Do similarly, we right-click and select Edit, the green-colored arrow that connects to the For Production task. Change the evaluation operation to expression and constraint. Then click the three little dots, then edit the expression as at user::v_environment, equal to production. Click the evaluation expression button. The result is a false. This is correct. Our current setting is not a production environment. Click OK to close the editor. Save the package. Now open the project parameters and change the production server name to a name that is not equal to the system machine name. We are simulating a non-production environment. Save the project parameter. Run the SSIS package. We see that the data flow task for development has been executed. Now, stop the package, then change the project parameters and change the production server name to a name that is equal to the system machine name. We are simulating a production environment this time. Save the project parameter. Run the SSIS package. We see that the data flow task for production has been executed. Wonderful, it works. Let's jump to the Oracle SQL developer and check the production dataset table. Execute the select statement. We got 4 records inserted to the production table. Let's jump back to Visual Studio and execute the package again. Check the database. We now have 8 records. This is wonderful. As I promised you to show how to remove the data truncation warning icon. So, the following is the extra bonus for you who have been following me this far. Now, right-click the data flow task for development, then edit the task. Right-click the blue arrow, then delete it. Drag and drop a data conversion to the data flow pane. Rearrange the position and connect the blue arrow from Excel source to the data conversion. Then connect the blue arrow from data conversion to the ADO.NET destination. Right-click, then edit the data conversion task. Click the checkboxes to import all columns. You have the option to change or not to change the output alias. So, I just do a demo to change the output alias. Make each column the same as its input column name. Also edit the name column data length. Change it from 255 to 20 characters to match the data requirement in the ADO.NET destination. Click OK to close the data conversion transformation editor. Now right-click, then edit the ADO.NET destination. We need to remap the column mapping. We need to map each column from the data conversion columns instead of the Excel source columns. After the remapping, then the data truncation warning icon on the ADO.NET destination would be removed. We perform the same procedure to remove the data truncation warning icon on the data flow task for production. Save the package and execute the package. Wonderful, everything works. I've just demonstrated how to set up an SSIS package that dynamically run based on a set of parameters and variables. You can deploy this package to a server, and it will decide its own environment and send the data to either a development or production database server. Enjoy the video, and if you have questions or suggestions, drop a comment below. If time allows, more content is on the way. Don't forget to subscribe and hit the like button if this was helpful. Thank you for watching.